Welcome to Domesticating AI, a biweekly podcast where we talk about practical AI for developers, and we help developers build useful AI systems reliably on hardware and budgets that they actually have. We want to start off with the news, and then we'll get into our main segment. The first thing is Chris over New Year's.
Hi, I'm Chris.
Oh my gosh, I forgot that part.
It's okay. We can do it now.
We can do it now because we have an editor.
We do, yeah.
We have freaking heck.
Isn't that so nice?
Yes. Okay, I'm Miriah.
Hi, I'm Chris.
And I'm Matt.
And yeah, we're running a podcast, and we can do the news now. I'm so glad we have an editor. Okay, so over Christmas break, because at software companies, sometimes we get a Christmas break like we're in school. And don't work for a week or two. That was me. Chris sent me a thing. We were talking about like building an AI box. Our friend was, and Chris sent over TinyBox, and I was looking at them. I thought they were super cool. It's like an all-in-one server that you can just buy and host your own AI. I don't think it's like necessarily for home labs, but like if you were a startup, I think it'd be super cool to just use your seed money to invest in that and not have to worry about variable cloud costs.
Well, if you're ready for the power draw, you can use it as a home lab, right? If you're just ready for that electric bill,
I'm not ready.
You're good.
Let me buy my solar panel for my roof first.
No, it's from the creators of TinyGrad. They're selling the hardware that they run their stuff on, and it's fantastic. I'm a huge fan of TinyGrad, and I especially like how device agnostic that is, which in AI is a huge deal. And yeah, they're just giving away their secrets almost for free. It's like 10K or 25K, which is why a startup would be a good place to grab it. But yeah, you get RAM that is severely underpriced compared to how it is right now. And you get GPUs that are probably severely underpriced compared to where they'll be in about 2 months. If you're going to pick one up, now's the time, you know?
Agreed.
Yeah, that's probably going to be true for a while. And it's hard to say like when the cliff is going to hit, but it'll...
Considering that our next news story was what on earth is happening with RAM prices and why are they like...
Right.
I didn't even realize there was a problem until I saw on Instagram that Samsung announced that they weren't using their own RAM for their phones. They were going to sell that instead and buy somebody else's RAM for phones because it was a better whatever their sales strategy thing is that they call them. And I just was like... And then I started freaking out. I've been planning to upgrade my 5090 box to 256 gigabytes of memory. And when I spec'd it out in December, it was $1,090. And then when I looked last night, it was like $3,000. And that's like a 200% increase. Like it was December 19th. It's been 3 weeks.
It's incredible.
Yeah, the industry is I was in this industry doing memory in the semiconductors, and like I know similar to Samsung, like Micron, they had a name brand called Crucial where they would sell their memory to the public. I
think the brand I was looking at.
Yeah, they actually, so they stopped selling Crucial because data centers and for AI and other things are all gobbling it up, and so they stopped selling straight to consumers and now are only selling to these data centers because the demand is so high. So it's interesting. The Samsung one is interesting though because that something they've always been doing, and what they're known for is because Samsung doesn't just have the semiconductor part, but they also sell refrigerators and phones and cameras or whatever.
I have their TV.
And so what they did is, whenever they would make chips, all the higher, they get graded into different tiers, and the higher tiers they can sell for really good money, but the lower tiers don't sell as well. So they would take those lower grade chips and put them into their products.
What does lower grade mean in this context? Is that just like the production process failed more on that chip, and that's why it's lower grade?
Yeah, so they might have to do more fuses or, to cancel out errors or other things. But it could also mean that they also have they're predicted to last for less time, right? And so like to get a memory into a car, for example, cars require really high grade because cars have to like survive in both freezing cold and really hot temperatures, and they like people don't want their car to die on them because the memory went out,
Can you
in like
imagine
a couple years.
Your car's RAM fails and it's just bricked now.
Yeah, now your entire car is bricked. Yeah, so everything that goes into a car always has to be really high grade, whereas something, for example, like those flash drives that you have, like people never expect those, one, they're not going to be plugged in a lot, and so and people don't necessarily expect a whole lot of them. So if they only last for like 2 years, no one really cares. And so there's kind of this grade of different products that you expect, and so that's why they rate it. But anyway, so it's just interesting to see that like Samsung is like going deeper into this sales strategy because of where the market's going.
Yes, because everybody wants AI. It computes not cheap. Like we're eating it up.
It's funny, yeah. What you were mentioning with the RAM prices, like I have this listing. The last time I bought RAM was in July of 2023. I was really excited. I bought 128 gigs, and so I have these two 32 gig chips that I put into my big box, like the box that I use for gaming. I was really excited because I can have the game up, and I can have YouTube up, and I can have Discord up, and I have way more than enough for all of that. But I had my old, like from when I actually built that computer, I had these two 16 gigabyte chips just sitting on my desk. And the RAM price increase, seeing that same listing, like if I go into Amazon and I hit buy again and I find that same RAM price listing, it's now almost $800.
Oof.
When I got it for $70 in 2023, almost 800, almost a 10x increase on that. And it convinced me, maybe irrationally, to just put the other chips in the box. So now I've got 96 gigs of RAM in this box, maybe for no reason. I'm just like, well, if it's on my desk, I'm gonna use it.
I just want
dumb.
more RAM. I'm just so I don't know.
Well, and we're gonna see SSD prices go up. We're gonna see consumer GPU prices go up. Like, unfortunately, the reality is, if you're looking to build your own, right now is when you should be buying to get stuff at a slightly inflated price rather than a hugely inflated price.
Cool. So for our main topic, today we want to talk about building your first AI at home, or your first AI home lab, or like
how do you start?
How do you start with your AI? Because you're building now, because prices are going up like crazy.
Yeah.
So I have found that when I talk to people that they don't know what an inference engine is, but they do know what Ollama is. So let's start with that. What is an inference engine, and why do you need it anyway?
Yeah.
I can start with that. This was probably like my expertise for a large part of my career. Is the inference engine is, you have a model, now you want to use it. You want to get it off of that data scientist. They trained this model. Back in the day, it was just like an sklearn model, but it often just lived on their laptop, and they were the inference engine, because you would go to that data scientist and be like, hey, can you run that analysis again? And then they would just, go to their terminal and run it. But like, obviously that doesn't scale. So the inference engine is in charge of turning that model into essentially an API, a REST API that you can query at any time.
I mean, that was people's jobs for a long time when we were manually training models. It was like, put this behind a thing and serve it as an API. And now that everybody's just going to foundation models, right? It's just the software that hosts that pre-built model for you.
Well,
sure.
It's that classic question. I mean, this is going to date us a little bit, but like, I remember in 2017 and 2018 doing Kaggle stuff, doing data science tutorials, doing machine learning tutorials, and all of them tended to just stop when the model was trained.
Yeah.
The inference engine is the now what, right? Now what? Inference engine. Something that's not keeping track of your gradients, something that is a bit more efficient, easier to run, and can just, you give it a prompt like people know, and it gives you something back.
Yeah.
It's pretty easy.
Yeah, and I mean, back then, the models weren't complicated either. So most
Back
of the
then,
the
3
Iris
years
data
ago.
set, and
Yeah.
the Titanic data set,
well,
the Boston housing data set.
well,
I
even
mean-
something where it's just like image generation or something like that. Like that was often, you weren't just dealing with text, you were dealing with engine or like images or maybe audio or something like that. But like generally the complication of it, 3, 4, 5 years ago was, hey, like, can we like make sure that the format and the data set all make sense, that we're returning things like the model version, we're making sure that the data is in a format that can be utilized, and just making sure that we capture a lot of this stuff that, if a software engineer got this model and quickly just set up a API and Go, for example, like they would probably just have input output, and they would probably forget all of these other important metadata that are around it. And so like that's what most inference engines were. They just, hey, give us a model, and all of a sudden all the wrappers, all the nice metadata that you want and keep was all kind of
The
attached to it.
hyperparameters that
Yeah,
nobody
your
knows about.
config as code.
Yeah.
Yeah.
I mentioned Ollama already.
Right.
What are other inference engines, and how do they like compare? Like I used Llama C++ because Chris introduced it to me 2 years ago.
Yeah.
He's like, you should use Llama C++ because I hate Ollama. I think those were your exact words.
Yeah.
2 years ago. And so I've been using Llama C++ ever since. But I've been trying to use Ollama for development. Like that's my thing. Like when I build with Ollama. I serve with Llama C++ or vLLM. But yeah, like, which are there other inference engines? Because I just named 3, and then why? Like, how do they compare?
I mean, there's a lot of them. Well, like there's TGI, which is probably a big one. That was
Text generation interface if you're Googling it.
yeah. That came from Hugging Face.
Yeah.
And that one was actually, it was way bigger than vLLM. And then Hugging Face, struggling to figure out how to make money, said, hey, we're going to close source this. And then once they
Is
did
that the thing behind whenever you host a transformer on Hugging Face?
Yeah.
Okay, because I know I haven't not doing anything cool. I know that like a big draw of Hugging Face 2 years ago was like serving your transformers on Hugging Face, and that's why people used Hugging Face was to like put their model in there and then serve the transformer. Okay, like I said,
It's good.
I use 3 things.
TGI is still good to this day.
Yes, it's still very good, but it's less popular now than vLLM because it went closed source. It's now open source again. If so you can get into it. It's still very, very good, but it lost a lot of that popularity to vLLM.
Well, and if
from
you're
that
already
decision.
familiar with transformers, diffusers, datasets, like the Hugging Face libraries and their ecosystem, that's probably the lowest barrier to entry of any of these. If you are a data scientist coming from using Hugging Face, and even for a lot of people coming from PyTorch, if you're on the training side of things, that's probably your easiest entry, is just TGI. It'll be very familiar to you, and it's fast, it's optimized, it's great.
Yeah, so all of these are specific to the more complexities of traditional large language models.
Right.
You got the old traditional server, so like Kserve, PyTorch serve. There's like BentoML.
Oh, I know what BentoML is.
Yeah, all of these are more traditional inference engines that are still around, still make a whole lot of sense. A lot of them you can serve LLMs on them, but vLLM is probably a better choice, like the larger the model gets.
Yeah.
So.
And I would probably, I have quite a bit of experience with, especially Llama C++, Llama CPP, vLLM, and EXO, which we haven't talked about EXO yet. I'd love to introduce that to especially people who have a lot of hardware sitting around and don't necessarily want to build a new computer just for AI or buy a new computer just for AI. EXO allows you to essentially bundle arbitrary hardware and create high throughput LLM inference engines with that hardware. I have it running right now in my basement. As part of this cluster, you have several Raspberry Pis of different generations. You have a Mac Studio M3 Ultra. You have an old iPhone 12. And Yeah, an iPhone 12 is part of the cluster, and it works really efficiently. Because they use tinygrad for almost all devices. For Apple ecosystem devices, they use MLX, which is amazing community-supported stuff. Outside of that one, which that's the one that, like, if you just have hardware sitting around and want to try, just start with that. Just install EXO on the devices. You'll find out it's very easy, and you can get a taste for what you like and how fast you want things to be. If that's not you, Llama C++ and vLLM are probably where I'd recommend that you start with, partially because Llama C++ is just very nice to set up on whatever you want, right? You can run this.
It like supports every GPU.
It supports everything. It's fantastic. It has a wonderful community that has put in a lot of work for that, including myself for some things. And like, we recently tested it at work where we had a cluster of 16 A100s, and it took a little bit of finagling, but it ran on 16 A100s, and it ran decently quick on 16 A100s. And the biggest thing that you have to deal with in those sort of setups is the latency between the GPUs, right? We'll talk about that too. So when you want something fast in that multi-GPU scenario and not necessarily something that just supports everything, go to vLLM. They've done a lot of that abstraction for you for multi-node setups, for absurdly high GPU setups, and like, it's great. All of these support OpenAI compatible servers, which that's huge for inference engines, because that means that you can hook it into Zed and Claude Code and Klein and Roo Code and Open Code and like any agentic coding software that you would want to use with these, you can.
Or like UIs, like the Open Web UI.
Yeah.
Those all do. What about
Open Web UI, Silly Tavern, all of that good stuff.
I found that a lot of people like Ollama just to get started really easy because it has like that built-in UI and stuff like that. And then the other one you've mentioned before was LM Studio, which
LM
is
Studio,
I feel it's very similar to Ollama. It's just like a download and run.
If you want just plug and play and you don't want to deal with any settings, you don't want to optimize it. Yeah.
I mean, I know Ollama has a serve mode, like you can download the binary and run it as a server, but I feel like Ollama and LM Studio are both really nice, like Mac developer laptop interfaces more than like hosting them.
They're good turnkey solutions for anybody that just wants to run it and not have to maintain it.
So now that you have, how do you have an inference engine, and then the next step is it's right. What model do you pick for you're setting up your home lab. You have something. I guess we should take a step back. It's like, do I need to buy a computer for that, right? Like, if we're going to set it up, do I need to go buy something? Because RAM's expensive. Do I need to go buy my tinygrad cluster? Or the other thing, too, is people are always like, well, I need to save up to get a GPU. That's the other thing I hear a lot is like they're trying to get a 5080 or a 4090, which they quit making 4090s. But, like...
Dude, go on eBay, buy a 4090D as soon as possible. That's what he told me last night. As soon as you can. Yeah, it's fantastic.
Like, do you need to buy a computer to have a home lab? Or a home self-hosted AI?
No. No, you don't. And I think that a lot of people want to with good reason, but like, you can download the Pocket Pals app right now and any number of other ones and just run it on your phone. You can use existing computers that you have, right? One of the pieces of an AI server that I have at my house is just an old Omen laptop from when I was a sophomore in college. And it runs great for what it's supposed to do, I mean, it's often, let's be honest, it's often an excuse, and I feel like I've used it as an excuse of, hey, I want to buy this more expensive hardware.
I have purchased 6 computers in the last year for my home lab. Like, I want to buy hardware. I'm not saying don't buy hardware. It's just like I don't think that should be the barrier to entry.
No. It definitely shouldn't be a barrier. You can get started and just get going and, start playing with the different models, playing with, different hardware configurations. And when I was earlier in my career, a way that like I forced myself to grow was by literally working on cheaper hardware. I had more expensive ones that made things easy, but like back then it was all about data, right? And so like if you wanted to do anything, you had to have really big data, and so that meant you needed lots of RAM. And so like if you just restricted, so like I restricted my RAM on purpose, so that way like it would force me to learn tools that required streaming the data through. I couldn't just load it all in pandas, which was like the only option at the time, right? And so there was so much I learned by pushing. And that's the same way, right? So
Can
like
you imagine loading your whole data set in pandas in your memory just for a project right now? Like,
okay, first of all, that you say that's weird, but that's DuckDB's whole business model. So continue, like.
But it's just
okay, gotcha.
But I mean, anyway, so the point is that like it's okay to have worse hardware because you will learn so much. Especially, I mean, that's a large reason to have a home lab and to
this
grow.
Sounds weird to say, but it's a little bit of an advantage, right? There's a reason why in our book in chapter 11 we talk about how to deploy it on a Raspberry Pi, and it wasn't just a Raspberry Pi; it was a Pi 3 4 gigabyte, right? That's how much you need as a base in order to have a model running that can work with agentic frameworks. And
I got a model at work running on a Chromebook.
Yeah.
Using WebGPU. Now it took 11 minutes to do an inference. So it's not like I was getting performance out of anything.
No.
But like if you can, the point being, if you can unlock a scroll Chromebook, you can inference on a scroll Chromebook.
Well, and it's fantastic too for those scenarios where you're like, I wish that I knew this thing. I don't really care to go research it right this second. I'm okay with it running for a second. I ask the question, I go do other things, and then I get a little notification. They're like, it finished.
Yeah.
It's like, oh, sweet. Now I know this thing.
I will say this, it also really helps because if you get deep into this, like there are points in your career where people have really bad architectural decisions, and the only way you can get them out of that decision is by doing it and proving to them that it's really bad. So, for example, lots of people just want to run AI on like Lambda, and
oh gosh,
Dude, we talked about that extensively.
Oh yeah, it's just like it's generally just a terrible idea.
I can't believe
but the
that
only
even
way,
came up.
but in their minds, what they've been using, like Lambda is just like the golden child. It can do everything, and so sometimes you just have to go and spin it up, and it's the same way. So it's just like learning how to deploy a model on a Raspberry Pi helps you really understand like the hardware constraints of doing something in like a Lambda, which is very similar, right? Like the hardware specs of an individual Lambda is very similar to what you might get in a Pi. And so
let's talk about that though. Like, let's say you were deploying on a Raspberry Pi right now. What models do you think you should use?
That was the next question.
Right?
What models do we pick, and how do we pick Like, I know that I have my way of picking a model is going to Discord and saying what model should I use, and then not doing that. I don't know. I guess I have, for my Twitch bot, I've just used Llama 3.1 because it's a Twitch chat bot.
Yeah.
It doesn't need anything else.
Yeah.
And then I know, this is like, if you want to know my weak point, it's like model evaluation, because like I know nothing about it. The other thing I've done is I know like you have to do specific things if you're doing tool calling. I wouldn't recommend doing that on a Raspberry Pi, but so I use Quinn for that. But like there's a whole lot that goes into model picking, and I think that's one advantage of like Ollama and LM Studio is they make that really easy. It's like you've got 10 choices, download one. But anyway, there's more. Let's talk about model picking and how do you pick models? Where can you get models? What do you consider?
I'm SSHing into my framework desktop right now
to see what models you have.
To see what models I have right there. Like these are generally models that I would say are, well, some of them. I'm only going to say the ones that I would recommend out of this because there's like DevStroll 2 123B on there. pretty much if you don't have one of the 128 gig Strix Halo boxes, just stay away from that one. But these are some that are pretty popular on consumer hardware.
Yeah.
And they're really effective for their size, right? You have GLM 4.5 Air. I hope that they release a 4.6 Air or 4.7 Air. That would, because GLM 4.7 is out. It's fantastic. Lots of people use it for many production scenarios. That's where we're at with that one right now, though. GPT OSS 120B and GPT OSS 20B get used extensively. I think that they're pretty good. And then the Nemotron models. I don't see a lot of people using these at home, but I see a lot of startups using them.
Yeah.
Especially like Nemotron 3 Nano, the 30B A3B, which is funny because that's based on the next one that I was going to say, the Qwen 3 30B A3B. These are smaller mixture of experts models that are fantastic for consumer hardware.
There's I think, what are, first I have follow-up questions. What are you use those for? The ones you recommended?
I use them
because I know you do a lot of crazy stuff. You're not like chatbot Chris. I mean, you have a chatbot running, but these are not your chatbot Chris models.
So some of them aren't like that. Qwen 330B that I'm talking about, that's the one that my wife likes querying most on our Open Web UI instance.
Okay.
And that's the one that my sons like querying most for like bedtime stories on that same Open Web UI instance, because it is really fast on the hardware that we're running it on, and it's pretty coherent and creative, right? I wouldn't use that model myself for coding tasks, but that's only because I have larger models that I'm also hosting, right? If that is where your hardware is at, it is extremely competent. And I'd probably say use the Qwen 3 Coder 30B A3B for your coding tasks. And for other tasks, use the Qwen 3 VL 30B. They're the same size. It's vision language.
I know.
model.
I know what it is. I was waiting to ask the follow-up question so Matt could tell us why they all have different letters after them and what that means.
Yeah. And then the last one that I have on there, this is the largest model on that box, is Qwen 3 Next. It's an 80B.
Yeah, I've looked at the next ones too.
It's great.
Okay.
It's fantastic.
Yeah, I mean, what I want to ask off of this is like these, in a year, probably 6 months from now, not even a year, like all of those models are going to change. So
were these the models you were using 3 months ago, Chris?
Yeah.
3 months ago, you were playing with Kimmy K2.
I was also using that one, yeah. No, this is the reason that I checked my framework desktop is because this is the one where I have it pretty static.
Okay.
And I'm just like, okay, I'll test out new consumer models here like DevStroll 2, but I'm not keeping that one around. These are the ones that I've kept around for a while, and I don't plan on updating anytime soon.
Yeah, I think we should let's talk about quantizations, because I know I get most of my models from Hugging Face. And like you'll get there's parameter size, there's quantization that I look for, and then usually they have some kind of like a fine tuning, like you said, Qwen 3 Coder, and that's a fine tuning pass that makes this better for coding. I tend to use the instructs on my Twitch channel just because of the audience I have on my Twitch channel. They're a bunch of nerds, and they like to be told what for. They like to play tricks on the model. Anyway,
Sure.
Matt, you said you used to be an expert on inference engines, so I'm sure you advised a couple of people on how to choose models for those inference engines.
Yeah, I mean, what I was kind of getting at with my previous question, though, is just like, I guess the first thing, let's answer your question is, yeah, you got the instruct, but they all come in different flavors, I guess you could call it.
Yeah, that's like, because they have
essentially, you get the base model, which is what you get after you train the model on the internet, essentially, which it's learned to do is next word prediction. But generally, that's not very good for whatever you're using. So generally, when you have like a chatbot, you want to train it to have conversations.
Yeah.
And so then you might see the chat
they do have
aspect. The other thing you'll see a lot is instruct. So this is often used for, Q&A bots, as well as this is generally what you want versus the base model. Generally, instruct is going to be your multi-purpose type model. You have reasoning models. Those are the models that have been taught to first think before it answers. So it just gives a whole bunch of, it just starts generating a whole bunch of text to give itself more context.
Should Llama C++? What are you asking it?
I don't mean to interrupt.
Yeah.
I just want to demonstrate. This is Qwen 3 Next running on the framework desktop, right? This is the Halo Strix, or the AMD Strix Halo. So it's not even a GPU, it's an NPU. I just wanted to show, like, I asked it, write me an acrostic poem about cloud providers spelling domesticating AI. This is a task that would be pretty difficult for a human. And it's doing its reasoning right now. And I'm going to tell you once it finishes, like, I'll read the poem and everything, but like, what were the specs? How fast did it go? Is that fast enough for you to use with OpenCode or with Klein or with something else, you know? Anyway, Continue.
Yeah, so anyway, so we have these other ones, like different flavors, which are just around what it's been kind of, in addition to the pre-training, it's also been, instruction trained or reasoning trained, etc. And all of those are to kind of squeeze out and kind of get the model to move in certain directions and how it was. So you got like coding and multiple other ways to do that. So you got to learn those things. But I would say in general, though, like, how do you first find the base model that you pick? And multiple ways to go about it. One is go to a leaderboard, find what's trending.
Yeah. Hugging Face has some great leaderboards for that.
But what I found is oftentimes nowadays, you can probably just, for most things, you could probably just pick the basic model and then this is generally how I do it. It's just like when I'm first starting a project, I just need a model that I can use as an example. I don't care if it gives me good results. I just need it to give, to act like an LLM. And then as the project gets more complicated, I just reach for bigger and bigger models until it's good. And I feel like nowadays, unless you're doing something really premier, very cutting edge, you don't need a cutting edge model. You can get away with so much with still most of the 7 models.
100%. And I hear that sentiment all the time, where Miriah mentioned, like, I played around with Kimi K2. Right now, the main drivers for like my really huge stuff are GLM 4.7 and Minimax 2.1 and what's that other one?
I don't know.
So yeah, we have GLM 4.7, GLM 4.6V for vision tasks, Mimo V2 Flash. That's a huge model and it's pretty good. Those are my main drivers for like really complex coding stuff. But the model that I use the most, like pretty by like a large margin, is ByteDance. It's Seed OSS 36B. That's not even on the framework desktop. That's on the Mac Studio, and that's on another computer at my house. That's the one that I give the most queries to, and I couldn't remember its name. It's really good.
Okay, we should probably start wrapping up then.
Okay, the acrostic poem's done.
I'm ready for your poem.
Do you want? It's kind of long. It's 15 lines because I had it spelled domesticating AI.
Yeah.
For people that don't know, an acrostic poem spells something at the beginning.
It starts with the letter.
Yeah.
Okay.
So the letters start spelling domesticating AI. Dawn of intelligence, gentle and near, offering tools that learn what you hold dear, making complex dreams simple and bright, every task softened by cloud-delivered light, seamless connections, devices in tune, training models to understand your room, intuitive helpers, kind and wise, customized care for your daily skies. Lots more like that. It's pretty good, right? It was generating at about 12.7 tokens per second. It took 154 seconds to generate this whole thing. But for that, right, this is part of the reason that we love local AI. That used almost 2,000 tokens.
That's not
Most
bad.
of that was in its reasoning. Yeah, it's not bad. That's way more than you need, but it's not bad. But I don't care how much it uses because
You're
I
not
don't have
paying
to pay
per
for any of
token?
it. Yeah, I'm not paying per token. I can do this as many times as I
love
want.
not paying per token. Today we talked about inference engines because there's a lot of them. I learned about a lot of them. If you were to just just recommend one inference engine to somebody and just say you're just gonna get started on that for hosting a model, what would you pick?
I think Llama C++ is like the catch-all.
Matt, which one would you like vLLM? Would you pick vLLM?
I wouldn't say that for someone to get started. It's I would almost say like Ollama, like just because
mean,
it
step
is so
back, yeah.
easy. It's
I was going to say just try, like, if you getting your feet wet, I would say grab Ollama.
Ollama serve Gemma 3, you're good.
Like,
Yeah.
the easiest thing to get your feet wet. That was my...
I just think it's really easy. I think in most work settings, what I found is Ollama is kind of the gateway drug. You get a model that's running on your laptop. It actually runs on your laptop. Everything's good. You don't need a GPU or anything like that because you don't need to understand about the models or anything like that. And then oftentimes people will just straight go to some API, OpenAI or other things. I think that's somewhat a mistake, but obviously that's going to be the next easy point. But then you start realizing, generally like, oh, you want to start self-hosting. So then it's like, well, Bedrock, you can do customized models on there, and it has a bunch of foundation models. That's what a lot of people go to with AWS. But like Bedrock is extremely limiting. And then once you hit, especially like what customized models it'll support and other things like that, that's really where I feel like vLLM shines, is when it's like everything you wanted to do that Bedrock just is nowhere capable of doing. Like,
yeah.
We talked about choosing. So choosing, if you were just to give one tip about like choosing something to look for when you choose a model, what's the most important thing to look for when you choose a model?
I think for me, I've developed like a prompt or a set of prompts that I use to judge whether an AI is going to be good for my use case. So you give them
the prompts to the AI.
So for me, that prompt is generally like, hey, generate me a prompt for an image generator that describes some abstract idea, like the state of tech in Utah. And then I give that to an image generator and see how well it does. If it's a great prompt, then yeah, probably this model is going to be decent for multi-hop scenarios and for understanding abstract things, which I prompt for pretty often, and that goes higher on my list.
Chris says have prompts. What do you say is your tip for picking a model?
I also have my own set of evals. You don't need a lot. It's just like 10 questions.
Yeah.
I would encourage everyone to come up with them.
Clearly,
just because
I need to have one of those.
You should.
Well, that's a hard thing, right? Going to the leaderboards and the benchmarks and everything, we don't have like a good way of just saying, oh, this is the best model at anything. This is the best model at this task. This is the best model at whatever. And so it's going to come down to your preference. And that's why we say, like, you don't necessarily need to buy into the hype of like, you must use a foundation model for X, Y, or Z. Because we don't know what your task is, so we don't know if it could be the best. You're going to be the one who's going to have to test that.
But I would just also say, like, don't stress picking the model. Most of them are they're comparable for most things you're doing. So just the key is to like, get it to the point where like you can use it locally and use the models, and it'll kind of open up what you want to do.
So me as a non-expert apparently in the room, I'll tell you what I do is I see how much hardware I want to run on, and then especially memory, and I make sure the model is at least half that size when I pick my quantization.
Great.
That's it. That's all I do. And it works.
That's awesome.
I know.
There's for that actually, for people who want to dig a little bit deeper into that, Llama C++, in their docs, they have a huge explanation of all of the different levels of quantization and which levels they recommend based on extensive testing for how much knowledge the model loses when it gets quantized to a certain level.
Cool. And we talked a lot about hardware. We learned Chris has a framework, Halo Strix thing that he loves and he runs everything on. And I have a 5090. I know Matt has a 5090.
Yes. I have a 3090. That's my
one
GPU.
Day we'll have social media and we'll just post a picture of all of the machines Chris has, and we'll just be like, there you go. That's it. We're going to put everything in the show notes. If you want to actually send that poem, I think we should put that in the show notes too. That'd be super cool.
Fun.
And again, once we'll have social media, we'll probably, if you have a home lab set up, we should all post pictures of our home labs in the thing. And then, and then people can follow up and do that too. I think it's cool. Find out ways to get in touch with us. I know that you guys are both speaking at Day to Day Texas, but you can find they don't record the talks, so
you can't find them.
You can't find them, but I'll be there. But we do record the talks for our meetup. So Chris and I host a meetup, and Matt was the first speaker I ever got, so honorary. He's always there. I have a data engineering meetup in January. Like I said, the speaker is talking about building an AI engineer, and you can find that. I stream all of the meetups, so that's why I'm okay with announcing them. The data engineering meetups every third Wednesday, and the MLOps meetups every fourth Tuesday. And then we're learning about tool calling at the MLOps meetup. And I don't have any other events coming up. Matt has another podcast. Podcast, how often do you release that one?
We do it once a month. So this is a podcast I'm doing with my company where we're just taking people through the journey of how we are doing AI transformation. And I think a lot of people might find it interesting. All the struggles of just going from, hey, like, what is AI? We talk from people that, from like our CTO and our president down to like engineers as well as like Scrum Masters and things like that. Just saying like, hey, how are you learning about AI? How are you figuring out this AI transformation? I think it's a very interesting story that we're telling.
Cool podcast. We'll see you next time.
Yeah.
Keep your AI on a leash.
I didn't even say, keep your AI on a leash.
That is... Yeah.